Today we are going to learn about a different type of functional dependency. I hope you all remember Sneha Sri. Thank you. The last class, functional dependency. I hope you all remember this slide, right? We have learned about functional dependency. Am I right? You know about the symbolic representation, and in between two columns how we can represent the relationship schema which is of having functional dependency, and what are the rules and how we can apply and test. This is the general formula. First of all, we have to test column, the left hand side determinant and the right hand side dependent. Okay, so left hand side determinant value, when you have to take, if there is everything is unique, then there is no need to check the y value. We can directly say it is fully functionally dependent. And in case of any duplicates are there, then take those value and compare its y value, right? So those two values you have to take and compare, and in that case both y also supposed to have same. If it is not same, okay, then we are saying it is functionally not dependent. Okay, so this is how we have identified what is functional dependency. With the help of it, you can design a good table design. And if it is non-functional dependency, okay, then we have to avoid such kind of designing tables. Okay, so here comes, there is a table which is given here, and in this experiment we are going to find out which are all functionally dependent and which are all functionally non-dependent relationships. Okay, consider, okay, so the first relationship they are saying, like, okay, consider here roll number and with multiple multi variables, and we are going to compare the single variable with the multiple variables, and finding out its dependency. So when you look at the roll number, everything is unique. So we no need to find out and compare with the remaining things. We can say this first relationship is functionally dependent. And inside that, when you take, okay, everything is going to be functionally dependent, but it must starts from roll number. Okay, when you take roll number and with the department name, so that time also it is functionally dependent. And department name, and department building, department name and department building. Okay, for example, here there is a duplicate, same repeated value, but it is mapped with the same corresponding y value, so it is functionally dependent. Second also functional dependent. So, third also functionally dependent. And last one, that is that is map one with another one. Okay, like roll number with name. Roll number with the name is already functionally dependent. And when you take roll number and name and compare with the department name and department building, that time also it is functionally dependent. So all these are functional dependencies. Okay, this is how when you create a table, yeah, it reflects a good design. But when you find out some of the, here also some of the invalid functional dependency, that is non-functional dependencies are exist. When you take name and department name, name with the department name, that is we are not taking roll number, go for name with the department name. Is there anything is repeated? Yeah, XYZ is repeated, but it is having Y value different, so it is non-functional dependency. So like that, some of the relationships are identified among this table. Also some of the invalid functional, non-functional dependencies also exist in this table. And in such table, okay, you should not keep the table design by this way. You have to break this table into at least two or more tables. Okay, so that is a way of avoid storing all the data in one single table. So when you do a big project and millions, that is thousands or millions of rows are there. Okay, definitely this much of conflicts will come. So you have to break down the table into small table, and you have to store the data. So that is why we are finding out the functional dependency exists between the tables. There are different types of functional dependencies. These are the four, and one by one we are going to see. First one is called trivial functional dependency. So trivial functional dependency is a kind of fully functional dependency. Okay, so how we have to write the mathematical expression is functional dependency of x to y if this y is a subset of x, right? Y is a subset of x, And here one more relationship, x to y x, also a valid functional dependency. X is not okay. So these three are going to match. Consider register number, and register number with the register number is a valid one, right? The same thing is register number, and register number is a valid functional dependency. And when you take register number and name, when you map with the name, okay, register number is unique, so definitely it is going to be a functional dependency, because name is a subset, right? Name is again a subset, and a subset, and okay, register number to register number represent x to x, and register number name and map with name, or register number and name map with roll number. That is in between that also any combination when you frame, that is also be a functional dependency. Okay, but left to right is important, and you have to find out and check the data, and you have to say. So if it falls within this three category, then it is called trivial functional dependency. And so trivial is always a valid functional dependency. You no need to check the table. Only the roll number, here it determines another roll number. That is, it is going to be a unique one. The second, or in mathematical, okay, theoretical way, how we can write this concept. Trivial functional dependency, a dependent is always a subset of determinant. Y is a subset of x, right? Y is a subset of x. That's why we have given y is a subset of x. So the same statement can be represented by this way. And okay, so then it is called the trivial functional dependency. See here, roll number, name, age. When you take roll number and name, okay, as x, and when you map with the name, okay, you can find out roll number, everything is unique. So definitely it is a fully functional dependency. And when you take roll number to roll number, okay, roll number only alone, if you take, that is also a trivial functional dependency. There is no duplicates, right? So when such kind of relationship is found in a particular table, then it is called trivial functional dependency. Non-trivial. Non-trivial means okay, how we can find out here, x intersection y is going to be an empty. Okay, there is no intersection. When you apply, there is no component which is going to be found. When you take register number and name, register number is a separate column, name is a separate column. Is there any data which is going to be common for register number and name? It is not going to be the same. But register number to register number, when you gave, okay, it is common. But register number to name, it is not going to be a common. Or register number to register number, comma, name, if you have given, then it is a functional trivial one, right? So if it is a non-trivial, there should not be in between any columns, there is no common data. Okay, that is going to be an empty set. Common tuples are going to be tuples with values are going to be present. So that is an empty set. So how to write a non-trivial functional dependency? Okay, so when you take, as I have told, register number to name, there is nothing. It is an empty set. Okay, but when you take register number to register number name as x, okay, one component x, okay, another component name and marks, if you take, in between that, okay, there is some matching data is there, that is name, and here also name. So at that time it is going to be, but when you take register number to name, it is not, okay, no common data, but this combination when you take, it is going to be semi-trivial. That is some matches are there. Some matches are there. Some of the data is partially matched. Okay, so then it is called this second one is called semi-trivial also. Non-trivial, maybe sometimes it is going to be it may contain some semi-trivial functional dependency relationship among the component. Okay, so non-trivial functional dependency, the dependent is strictly not a subset, but previous one it is a subset, but here it is not a subset. When you consider this, how to write it? Okay, so in mathematical expression, by this way you can write. And consider an example: roll number and name. Roll number and name, everything is unique. Okay, and take another one combination: roll number, name, and age. Okay, roll number, name, and age. In this table, the age contains different values for different names, right? So in this part, it is having a different value, so it is not going to be a functionally dependent. Okay, so non-functional dependent, there is no common data present between this roll number and name. There is no common values. Roll number register, roll number, name, and age also. There is no common values. There is no the x intersection y is going to be an empty one. Okay, so that is why it is called as non-trivial functional dependency. And the next one is multi-valued. Okay, multi-valued functional dependency. Consider, okay, entities of the dependent are not dependent on each other. So this B to C is not dependent. Okay, A to B C, when you take B comma C, when you take in between these B and C, there is no functional dependency exist. Okay, then it is going to be a multifunctional. So why it is, okay, it is similar to second one, non-trivial. Non-trivial, we have compared one element. Okay, one element, single element we have verified here. And the same kind of non-trivial which exists between more than one element comparison, then it is called multi-valued functional dependency. Consider here roll number, name, and age. Roll number is unique. Okay, fine. Second name you have to take. There is ABC and ABC which are repeated but which is having different ages. So here in the right side, there is no functionally dependent. So we can say the B and C are not, that is more than one value is there and they are not functionally dependent. So hence it is called as a, this table falls under the category of multi-valued functional dependency. Okay, as well as when you take name to age or age to name, among this combination of left side, okay, sorry, right hand side, among this component name to age or age to name also, when you find out there is no functional dependent, that means there is no unique value. Okay, for okay, name to age, ABC is having different, first and last is having different values. Age to name, when you take, okay, here some of the common data is 1818, but it is mapped with different values. So here there is no functional dependency. Among this B to C, C to B also doesn't have any functional dependent. So is right hand side which contains multiple value, and here also y x intersection y is an empty one. Okay, but y represents here y1 and y2, like that, two more multiple columns one. Okay, so when you consider for comparison, then it is called multi-valued functional dependency. Then the next one is called transitive functional dependency. As we have told, A to B and B to C, that alone if you take, okay, and then it is called transitive functional dependency. Consider here enrollment number, everything is unique. Yeah, a department when you take, okay, so that is functionally dependent. But when you take department with the building number, okay, there are something take, okay, EC and EC both are having same value. Okay, so both are functionally dependent. Any direction, A to B, B to C. According to axiom of transitivity, A to C, there is a direct, okay, the dependent is going to be indirectly dependent or on determinant. So here fully functional, but the transaction is from A to B and B to C. When you verify, here the transitivity is going to be an indirectly dependent. We are saying, okay, directly dependent is the first one, trivial. How we can say x to y directly, we used to say if there is a dependency, okay, then we said it falls under trivial. Instead of writing A to C, A to B, and when we break down this mapping, okay, then it is falls under the category of transitive functional dependency. Here also x is a subset of y, like that. Okay, same thing, A and B and C are everything. When you do an intersection among this element, definitely some common values are going to be there. Okay, so that is called transitive functional dependency. So there are four type of dependency: trivial, non-trivial, multi-value, and transitive. Trivial, everywhere it is functionally dependent. X union, okay, sorry, y is a subset of x. And non-trivial, when you take X intersection y is going to be an empty set, and multi-valued, the same thing when you apply with the more than one a multi-valued element, okay, then it is called as multi-valued, but similar to non-trivial. Last transitive is similar to trivial functional dependency, because in transitive functional dependency there is a indirect way of dependent or determinant is having a functional dependency. Okay, some common element. It is a subset of elements are going to be present. So this is how in a particular table, what type of dependency exists, you can able to classify. Okay. Next, okay. So with this topic, I'll just wind up the topic of functional dependency. Could you please anyone send attendance? Speak. Okay. Okay, chat. Very good, Sneha. So hope you all understood functional dependency. Have you all understood functional dependency? Shall I get your answer? 11 students, 10 students are here, including me, 11. Shall I get your answers? Yes or no? Functional dependency. Shall I get Y or N after this chat? In the chat, okay, can you give your answer? Functional dependency, Y or no? Yes or no? Give me an answer. Press the key, Y or N. Have you all understood the topic completely about what is functional dependency and what are the different type of functional dependency? When you when you look at a table, you have to find out it relations. What are the different type of relations exist between different columns? That alone we have learned it. Yes, okay. We'll move to the next topic. Okay, I have posted those links in the Google Classroom. Okay, I'll just take that links. So with this, we have finished. The topic I'll just show, because 28th onwards your third internal exam starts, and we have few more, six more classes. Okay, so with this I think I will finish the entire portions. Okay, yeah, I'll try. So today we have learned functional dependency. It's completed. Am I right? Next topic, this alone left, that is called set operation. Okay, so we are going to learn set operation. When we learn this, okay, fifth module is completed. So I'm going to start the topic set operations. So it is very simple. Set operations. Okay, if you have, okay, you can also open the link if you want. Software engineering, sorry, essentials. I have posted some of the links here. Set operations. So functional dependency I have posted already. Okay, I'll just stop this video. 1 minute. Uh, and then I'll